Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good evening to all of you. So let's continue our chapter 1. Okay, chapter 1, part 3. This is calibration and noise. Okay, so first is the calibration. So for this topic, for topic 1, I just focus on the surface for the calibration. What is the definition of calibration? Okay, and also the noise lah. Alright. For the calibration means to compare a given instrument against a standard instruments to determine its accuracy lah. Okay, that is the calibration. That means before we do some measurement, so we have to calibrate our instrument and then calibrate, then we can do the measurement lah. Okay, for example, like our oscilloscope, first we have to calibrate. So for example, like digital oscilloscope, so we have to calibrate first before do the measurement. Then after we calibrate, accept, so we can do the measurement lah. That is standard for calibration. Alright. So in this chapter, the calibration of DC and AC voltmeter, DC and AC ammeter and ohmmeter will be discussed. Okay, for this one, I will skip first. Okay, so we just proceed on the surface for the calibration. All right, so just a definition of the calibration. So the next I will cover for the calibration on the AC. Okay, on the AC and voltmeter. Okay, voltmeter or DC and AC and meter lah. So it will be next chapter. After we focus on the DC voltmeter or AC voltmeter, so we focus on the calibration part. Right, and then also another one is the potentiometer. How to calibrate the potentiometer also will be discussed for the next topic. Okay, for this one, only if we focus only what is the calibration. Okay, calibration is to compare the given instrument against the standard instrument to determine its accuracy. Okay. So calibrating the analog instrument. In calibrating a DC voltmeter, a few instruments such as a voltage regulator, resistor, potentiometer is used as the standard measuring instrument. Right, so the standard instrument is the instrument which comply the international standard, and it can be used to calibrate the measuring equipment in the laboratory industry. So normally digital instruments such as a digital multimeter usually have a high accuracy and high precision, right? So thus it can be used as the standard instrument to calibrate the others analog instrument. Okay, for example, like our digitals. Okay, so this this is our digital multimeter. So this one we can use to calibrate other component other analog instrument. All right, follow the standard. Okay, so this one I will be skip first because this is will be covered on the DC voltmeter. DC voltmeter, after we cover on the theoreticals on the DC voltmeter, we study about how to calibrate our DC voltmeter. So this one also we skip first. Okay, we go for this one also calibrating the potential meter circuit. So this one I will skip first. Okay, so we focus on the next is the noise lah. So this is details in the, for example, the voltmeter. All right. So this calibration on the potentiometer, also the will be covered for the next topic. So okay. So we go for the noise. We go for the noise. Okay. Noise is for electrical noise is any undesirable electrical energy that fall within the passband of the signal lah. So you can see the figure 6.9. I will show you after this. Show the effect of that noise has on the electrical signal. For example, like I mentioned to you, if you have the DC, okay, DC is the direct current. Okay, direct current is normally we have a straight, but if you measure using the oscilloscope, using the digital, so actually we have this noise on our output. We have the noise. This one we call the electrical noise. Okay, so the grassy looking squirrels superimposed on the sine wave electrical noise which is contain the multitudes of frequency and amplitude that can interfere with the quality of the signal. Okay, for example like this. So this is the we call the signal without the noise. That means this is ideal sinusoidal. So this is ideal. Actually, so in our measurement like this, we have a lot of noise here. That's why we have to use the filter. Okay, you have the AC filter. Okay, AC regulator to filter this output should be like this. Okay, to be ideal. Okay, signal without noise. So this one, the signal with noise lah. So this is the effect of noise on the signal. So normally it's similar like our DC, our DC current. So also we have, if we have the straight like this, maybe we have a noise lah. Okay, we have the signal with the noise. Alright, so the noise can be divided into two general category. First is the correlated noise, and second one is the uncorrelated noise lah. Okay, so the correlation implies on a relationship between the signal and the noise lah. So correlated noise exists only when a signal is present. So uncorrelated noise present all the time, whether there is a signal or not lah. Okay, that means, so the correlated noise, okay, you have to remember this one. Correlated noise exists only the signal present. Okay, so uncorrelated noise present all the time, either there is a signal or not. Okay, so for we go for the correlated noise. Okay, the form of internal noise present only when there is a signals. Okay, so it's no signal, no noise lah. All right, so produced by nonlinear amplification and includes harmonics and intermodulation distortion. Okay, distortion, hence nonlinear distortion lah. Okay, so the correlated noise harmonic distortion occur when the unwanted harmonic of the signal are produced through nonlinear amplification. Okay, harmonics integer multiply of the original signals. So the original signal is the first harmonics called fundamental frequency. Okay, 2 times fundamental frequency. Okay, second harmonics. Okay, and then we have third harmonics, we call it harmonic, and so on. Fourth harmonic, fifth harmonic, sixth harmonic, and so on. Okay, also called the amplitude distortion. Okay, so the correlation, okay, intermodulation distortion in the correlated noise. Okay, generation of unwanted sum and difference frequencies produced when two or more signal mix in the nonlinear device. Okay, sum and different frequency are called cross products. Okay, and unwanted cross product frequencies can interfere with the information signals. Okay, so this is intermodulation distortion. Alright, so for uncorrelated signal can be subdivided into two general categories. First, internal, and second one is the external lah. Okay, external and internal. So external generated outside device or circuit, that means outside from the circuit or instrument, and internal will be generated within the device or circuit lah. So that is internal, that means from internal circuit or internal device. For external, outside lah, for outside device or outside the circuits. Okay, so this is some example of uncorrelated noise. Okay, you can see this one. For external, we have the atmosphere. Okay, extraterrestrial. Okay, solar, cosmic, man-made, impulse, interference, and so on. Okay, so this one we call the external correlated noise. Okay, for example, internals, thermal, shoots, okay, transient times. So this is internal uncorrelated noise lah. Alright, so for uncorrelated noise, for external atmospheric noise, okay, electrical disturbance that originate within the Earth's atmosphere, okay, commonly called the static electricity. Okay, for example, like sputtering, crackling, okay, often heard from a speaker, okay, when there is no signal present. For example, when we have no signal, so on the speaker we heard about the crackling. Okay, the signal lah, the signals. That's we call the atmospheric noise. Right. So uncorrelated noise. Okay, extraterrestrial noise originates from the outside Earth atmosphere. Okay, also called deep space noise. Okay, divided by two categories is a solar noise. Okay, solar noise generated directly from the sun heat. Okay, cosmic noise continuously distributed throughout the galaxy. So noise intensity is the relatively smaller, very small. Okay, that is for cosmic noise. Okay, the next for uncorrected noise is on the external is the man-made noise lah, produced by mankind. Okay, part producing mechanisms such as a commutator in electrical motor, automobiles, emission system, AC power generating equipment, and so on. Okay, the most intense in the more densely populated metropolitans and industrial areas. Okay, also called the industrial noise. Okay, this one also we can the man-made noise also we can call as the industrial noise. Right, so for impulse noise is the high amplitude peak of short duration in the total noise spectrum. Okay, sudden bursts or irregularly shaped pulse that generate lasts between a few microseconds and several milliseconds. So common source include the transients produced from electromechanical switches, okay, electric motors, okay, power lines, ignition systems, pure quality solder joint, and so on. Okay, that is for impulse noise lah. And then for interference, interference for the external uncorrected noise. So when information signal from one source produce frequency that fall outside their allocated bandwidth and interfere with the information signal from another source. So for example, citizen band radios transmit signal in the 27 to 28 megahertz. Okay, their second harmonic frequency is 54 to 55 megahertz. Okay, fall within the band allocated to the very low, very high frequency television. So if the if the citizen band radios produce the high amplitude second harmonics component, it could interfere with other people television reception. Okay, so this is one we call the interference. Okay, when we have two more than one signal within the bandwidth bandwidth. Okay, so next is the for internal uncorrected signal is the thermal noise. So thermal noise is rapid and random movement of electron within a conductor due to thermal agitations. Okay, present in all electronic component and communication systems. Okay, often referred as as a white noise. Okay, so uniformly distributed across the entire electromagnetic frequency spectrum. Okay, that is for thermal noise lah. And then another is the short noise. Short noise is the caused by random arrival of carriers, holes, and electron at the output element of the electronic device, such as a diode, FET, and or bipolar transistor. Okay, sometimes called as the transistor noise. Okay, additive with the thermal noise lah. Okay, next is the for the last. Okay, on the internal uncorrected noise is the transient time noise lah. So any modification to the stream of carrier, okay, holes and electron as they are passed from the inputs to the output of the device, such as from emitter to collector of the transmitter, produce an irregular or random variations. Okay, so carriers suffer from the emitter time delay, base transit time delay, and collector recombinations time delay and propagations time delay lah. So if transit delay are excessive at the high frequencies, okay, the device may add more noise than amplification to the signals. Okay, so this is a internal transient noise lah. So this is some noise that occur when we do some measurement lah. Okay, that you have to know this is some basic noise lah. Okay, so for example that we have the uncorrected noise, we have two. Okay, two uncorrected noise is the internals and external, so you have to know lah. Okay, so this is okay, external noise, and this is the internal noise lah. So actually that I mentioned to you, so the noise can be categorized by two categories lah. First is corrected noise, and second is the uncorrected noise lah. So corrected noise normally is we have two lah, corrected noise and corrected noise. The corrected noise exists when only when a signal is present. Okay, uncorrected noise present all the times. Okay, whether there is a signal or not. Okay, so this is two type of noise lah. Okay. All right, that's all for today for the noise and calibration. All right, so make sure you have to know what is the type of the noise. This is a theoretical for the noise. Okay, we have two basic noise. Okay, on the corrected noise and uncorrected noise, they have another noise lah. Okay, another noise that you have to know. Okay, we have the external noise and internal noise, and also to calibrate lah, calibrate our instrument or our measurement device. So this we will cover after this for the next topic. Okay, for topic number 2 or number 3. Okay, so that's all for today. Okay, first you have to know what is the calibration, and second one is you have to know what is the type of noise. Okay, so next we focus for chapter 2. Okay, go for chapter 2, and then if we see this how to after we cover on the DC voltmeter, AC voltmeter or AC emitter, so I will cover for the calibration for calibration. Okay, that's all for today class. Okay, thank you very much. See you for next week.